Hello and welcome to the AI Research Roundup. I'm your host Alex. Today we're looking at a paper titled CoMotion Concurrent Multi-Person 3D Motion. This work introduces a way to detect and track detailed 3D poses for several people at once, all using just a single camera stream. It's designed to keep track accurately, well, even in crowded scenes with tricky poses and occlusions. A key idea here is that instead of matching separate detections across time, the model learns to update the poses directly from the new image, which is great for online tracking when people might be blocked from view. Right, and we can see some examples of this in action in Figure 1. It shows a couple of video sequences. For each one, you see the original input, then the 3D poses tracked by CoMotion, represented by those colored overlays, and also a comparison with another method called 4D humans. What's really clear, especially in the areas highlighted by arrows, is how CoMotion manages to track distinct individuals, even when they are partially hidden or overlapping. This visual really drives home how that learned update mechanism helps maintain the tracking through those tricky occlusions. Building on those visual results, Figure 2 gives us a schematic overview of the CoMotion system itself. You can see how an input frame first goes through an image encoder to get image features. Then, these features are used in two ways simultaneously. A detection module identifies potential new people, while that learned pose update module we mentioned takes the existing tracks from the last frame and updates them using the new image features. There's also a pose matching component that decides whether to start new tracks or drop old ones. And the inset really zooms in on that crucial pose update module, showing how it uses attention mechanisms and recurrent states, like a GRU, to process the information and output the updated 3D poses and hidden states. Okay, so now that we have a sense of how CoMotion works, let's look at some numbers in Table 1. This table shows the tracking performance on the PoseTrack 21 dataset, comparing CoMotion to several other methods. They report metrics like MODA and IDF1, where higher scores mean better tracking accuracy and fewer identity switches. You can see CoMotion gets really strong results, especially after they fixed a bug in the evaluation code, scoring 71.4 on MODA and 79.5 on IDF1. That's a big jump over the prior state-of-the-art, like 4D humans, really showing the effectiveness of this learned update approach for tracking. Okay, so Table 2 gives us a bit more detail on those PoseTrack results, comparing performance on PoseTrack 18 versus PoseTrack 21. The text notes that the annotations in PoseTrack 18 were incomplete, and PoseTrack 21 is the recommended benchmark now because it fixes that. Looking at the PoseTrack 21 columns, we see those strong tracking scores for CoMotion confirmed again, that 71.4 MODA and 79.5 IDF1 we just discussed. But what's really striking here is the speed. CoMotion achieves almost 6 frames per second, while the reproduced 4D humans method clocks in at only about half a frame per second. So it's not just accurate, it's significantly faster too. Beyond the tracking performance and speed, Figure 3 also looks at the quality of the 3D pose estimation itself. The top part is a table comparing CoMotion to other methods on standard pose datasets, like CoCo and PoseTrack, using metrics like PCKN and MPJPE. You can see CoMotion is competitive, achieving strong results particularly on 3DPW. And it maintains good accuracy even when looking at the full image, instead of just cropped single figures. Below the table, we see another visual comparison over time, similar to Figure 1, but here it really emphasizes the temporal stability. Notice how the CoMotion poses flow smoothly frame to frame, while the 4D humans predictions, especially that green figure on the right, seem to jump around a bit more abruptly. This really shows the benefit of that learned update mechanism for generating coherent motion. And speaking of those PoseTrack results we saw in the tables, Figure 5 actually highlights an important detail about the evaluation itself on PoseTrack 21. This dataset uses these special ignore regions. You can see one marked out in blue here, basically to handle areas where annotations might be missing or unreliable. The issue was, As shown on the right, the original evaluation code incorrectly penalized predictions, those red boxes, even when they fell within these ignore zones. So the authors fixed this bug, which helps clarify how they achieved those improved scores we talked about earlier. Building on that point about evaluation nuances, Figure 4 shows a related problem, but specifically with the older POSE-Track 18 dataset. We just saw the ignore region issue in POSE-Track 21. Well, POSE-Track 18 suffered from incomplete annotations altogether. You can see here how perfectly reasonable predictions, shown in red, are marked as false positives simply because those people weren't labeled in the original data. This really underscores why POSE-Track 21 is now the recommended dataset for evaluation. Okay, so seeing those evaluation nuances really highlights the challenges here. What CoMotion offers is a strong method for handling multiple people simultaneously, getting both their track and their 3D pose with impressive temporal smoothness. This ability to understand complex human motion jointly is crucial as AI moves towards richer scene understanding. Well, that wraps it up for this episode. Thanks for listening to the AI Research Roundup. I'm your host, Alex.